In this video, I'd like to do several problems that involve 0. So for example, if I had to take a number like 7 and add 0, or if I was to take the number 7 and subtract 0, I'd like to point out that adding 0 and subtracting 0 give you the same thing. On the number line, you could think of it as that you're at 7 and we are to move 0 units, which means don't move at all, stay still. And subtracting 0 would also mean to move 0 units, which would mean to stay still. Or you could think of it if you had $7 and you neither gained any or lost any, your situation would not change, leaving you with the number 7. So the answer to both of these questions is that it's equal to 7. Notice that this argument would also work with negative numbers, adding or subtracting 0, because the concept is the same. If you were at negative 7 on the real number line, adding or subtracting 0 would mean that you are not to move at all, or you could think of it as you're to move 0 units to the right or left. Either way, you'd be sitting still, meaning that both answers would be negative 7. Another way to think of it is if you owe somebody $7, you're in debt $7, so that would be negative 7. Adding and subtracting 0 could be thought of as that you neither add or subtract to your debt, so since the situation didn't change, you'd be left where you started with. So you started at negative 7, you would end at negative 7. Another fact involving 0 that I'd like to point out is that if ever you have a number, say A, and you subtract that number, anything subtract itself comes out to be 0, regardless whether A is positive or negative. So for example, if you had the number 3 and you took 3 away, you could think of this without the real number line, just in terms of if you had $3 and you took 3 away, you would have 0 left. Had I given you the problem involving negative 3's instead, it would be a similar argument. Anytime you take a number and subtract itself, you will get 0. So this is just another example where I have a number here and it's the same number here and I am subtracting them. You will always get 0 in this case as long as they are the same. So you can think of negative 3 is that you have a debt of $3. This negative 3 could be thought of as a debt of $3. And because you are subtracting them, you can think of it as you're taking it away. So you have a debt of $3 and you are going to take away your debt of $3. So if you were to take away your debt, you don't owe any more money, so this would give you 0. You don't have money and you don't owe money. If you like the chip model, you can think of it as you have 3 negative chips, and that this symbol means you're supposed to take away 3 negative chips. So if you have 3 negative chips and you take away 3 negative chips, you're left with nothing or 0. Another way to think of the problem is you could change the subtraction problem into an addition problem. You'd have negative 3. You'd leave that sign alone. You could change the subtraction problem to an addition problem only if you change the sign on the second number. So changing the subtraction to an addition and then changing the sign on the second number would give me a positive 3. And then one way to think of this is that you're at negative 3 on the real number line. That's here. Adding 3 would put you 3 units to the right, which would have you ending at 0. Another problem involving 0 is if I start with 0 and I add, say, a negative amount, you could think of this as you're starting at 0 on the real number line, and if you were to add negative 7, that would mean that you need to go 7 units to the left or in the negative direction, and if you did that, that would put you over here at negative 7. So 0 plus negative 7 is negative 7. Another problem that involves 0 is if you have 2 numbers that are opposite in sign and you are adding them. So for example, if you had negative 5 and you added 5, you could think of this problem as you have 5 negative chips, if you like the chip model, and you're going to add 5 positive chips. And since 5 of them are negative and 5 of them are positive, they cancel each other out. A negative chip and a positive chip cancel each other out, so each of the 5 pairs would be 0, And this is because the number -1 and the number +1 sum to 0. So you would have none left. So this would be equal to 0. The other way to think of it is -5 on the real number line is right there, 5 units to the left of 0. And adding 5 would mean you are to move 5 units to the right. 1, 2, 3, 4, 5. Either case, you end at 0. Notice if I switched the order and put the +5 first and then the -5, that would look like this. And you could use the same argument. The chip model would be the same thing, except you'd be putting the positive chips down first. There'd be 5 of them. And then you would be adding 5 negative chips. In either case, you'd still end up with 5 pairs of positive negatives, and they would cancel each other out. Since there's the same number of positives here and the same number of negatives here, when you pair them up and cancel them, you'd end up with no chips left, so this would be 0. If you like the real number line, you could think of it as you're starting at +5, but if you're adding a -5, that means you are to move 5 units to the left, 1, 2, 3, 4, 5, and again, either way, you end up with an answer of 0.